Hi, I'm Roxanne Martin from Mr. Farrar's Period 3 Calc AB class, and today we're going to be doing an AP problem from the 2010 FRQs. So, this problem is number 3, and it reads, there are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph above shows the rate, R of t, at which people arrive at the ride throughout the day, and t is measured in hours from the time the ride begins operation. So let's start. Part A. How many people arrive at the ride between t equals 0 and t equals 3? Show the computations that lead to your answer. So what we're being asked for here is the number of people that arrive at the ride. So since we're given R of t, this is the graph, this is of R of t, we're just looking for the integral from 0 to 3. So the area under this curve from 0 to 3. And that's going to show us how many people arrived at the ride during those first 3 hours. So if we write it in integral notation, it'll look something like this. The integral from 0 to 3 of R of t with respect to with respect to t, dt. Okay, there we go. And now we're just going to look at this. So it's two trapezoids, if you can see, but we can even break it down more than that just to make it really simple. And it's two triangles and two rectangles. So then we can just go through and making sure that we see the units on the side there. So that one unit for the y-axis is 200 and not 1. So go through and just add that all together, and then whatever area we get underneath that will be the number of people that arrive during those first 3 hours. So once we go through all of that and add it together, we're going to get that 3,200 people were in line during the first 3 hours. So if we did it with the trapezoids, you would get the same thing. I just wanted to break it down a little bit more and really just show how simple it is. So there's our final answer for part A. So now for part B, the question is the number of people waiting in line to get on the ride decreasing or increasing between t equals 2 and t equals 3? So since the rate at which people ride the ride is actually 800 people per hour, we're just going to see if during that interval from 2 to 3, whether the rate at which people arrive in the line is greater than or less than 800 people per hour. And if it's greater than, then that means that the line is increasing rather than decreasing. So now let's look at the graph on that interval. So from 2 to 3, that little segment right there, and we're going to see that it is always above 800 during that time. So now it's greater than 800, or not always, but for that segment from 2 to 3. So since the rate at which people are arriving in line is greater than the rate at which people are getting on the ride, then the line is increasing on the interval from 2 to 3. So between the second and the third hour, the line is getting longer. So now let's move on to part C. So the question reads, at what time t is the line for the ride the longest? How many people are in that line at that time? Justify your answers. So that time when the line is going to be the longest is going to be when R of t is equal to 800. So when the amount of people arriving is equal to the amount of people getting on the ride. So that's going to be at 3, 800. So at that t equals 3. But just to check, so on the interval 0 to 3, R of t is greater than 800. And then on the interval 3 to 8, R of t is less than 800. So it's at 3 that R of t is equal to 800. So now we need to find the number of people who are in that line at t equals 3. So it's in the question right here. How many people are in the line at that time? So at time t equals 3, there's a couple of different components that we have to think about. So first, we have to think about the people that were in the line before the ride even started. So that was given to us in the initial problem, and that's going to be 700 people. The next thing that we have to think about is the number of people who have arrived in the line since the ride opened, so in those first 3 hours. And that question sounds pretty familiar, right? So thankfully, we've already done that. So that was the integral that we did in part A, that integral from 0 to 3. And the answer for that was 3,200 people. So for the people who arrived in the line in the first 3 hours, that's that 3,200. So the people who have arrived in the line, or have waited in the line during those first 3 hours, whether they arrived before or after the ride opened, is equal to 3,900. But there's something else. We have to subtract the number of people who have actually gotten to ride the ride. So we have the rate at which people get on the ride, and which they ride it, obviously, and that's 800 people per hour. So in the first 3 hours. So now that's going to be 800 times 3. And our final thing is going to be 700 plus 3,200 minus 800 times 3 to show that there's 1,500 people that are waiting in the line at time t equals 3. Okay, so finally we're at part D. So the question is write but do not solve an equation involving integral expression of r whose solution gives the earliest time t at which there is no longer a line for the ride. So the time when there is no longer a line for the ride is the time when there's 0 people in line. So whatever this equation is, it's going to be set equal to 0. So we're going to start with the initial number of people in line. So that's that 700 from the very beginning of the problem. So we have to get rid of those first 700 people to eventually get to having no people in the line. And then from there, we have to add from 0 to time t, so an integral from 0 to t of some variable other than t. So we can just use x here, so of r of x dx. Next, we're going to subtract the number of people who are actually getting to ride the ride. So that's 800t, because 800 people ride the ride every hour. So the integral in the middle is the people arriving in line, and the last piece, 800t, is the people riding the ride. So when that 800t becomes bigger than the 700 and the integral in the middle, when they cancel it out and so that the entire thing is equal to 0, that is when there's going to be no line for the ride. Okay, so now let's score all of the work that we just did and see if we got it right. So I'm going to take the work that we had from before, and here I have the scoring guide. So for part A, let's just take the part A work. And we're going to see that on the scoring guide here. And 1 point is for the integral, so we had that right here, so we got that 1 point. And then the other point was for the answer of 3,200 people. And look, we have that too. So perfect, we got both points for part A. So now let's go to part B. Here's the work for part B. So for part B, there's only 1 point possible, and that's the answer with the reason. And so we have that r of t is greater than 800, therefore the line is increasing. So the number of people waiting in line is increasing because people move onto the ride at a rate of 800 people per hour for t between 2 and 3, and r of t is greater than 800. So that much is what we have here, so perfect, we got the point for that one too. Now let's go on to part C. So part C has 3 possible points. It identifies t equals 3 as the only place that r of t is equal to 800, and as the number of people in the time when there's the most number of people in line, and then the total number of people in line, and then justification for this. So for part C, we have this. We identified t equals 3, so perfect, we have that first point. And then the second point is here, where we have the number of people total, so 1,500. So we have that point as well. And then the justification for it. So the justification was kind of spread out for us here, but we have this entire sentence here that is on these 2 pages. There's our justification, so there's our third point. Finally, there's 3 more points possible for part D. So for part D, there's 800t, that is 1 point. So we have that, so there's a point. And then the integral as a whole, So this integral right here. And then the final answer. So since our answer matches what is on the answer key, perfect, we got both of those points. And we just got a perfect score on our AP Calc FRQ. So if you need any more help, I just looked up FRQs sorted, or AP for response sorted, and I came to this website from the Arkansas School of Mathematics, and they have a bunch of the AP FRQs, the AP Calc FRQs that are sorted, and when I kind of looked through these to find the ones that were most similar to the question that we just did, and the category that had the most like us were the Riemann sums and accumulation. So if you go to that page 99, they have a bunch of problems. So this one is like the third problem from 1999. And it's a kind of rates problem that asks a lot of the similar integral questions that were on the problem that we just did. So here it's a table instead of a graph, but if you keep scrolling down, there's some more table ones, and just a lot of these are really similar to the one that we did before. They all have something related to integrals, and some of them are with the graphs. So I thought that this was super helpful, and I did some of these practice problems when I was going through and trying to get better at this kind. So I hope that that's helpful, and these all have the scoring guides, so it's easy to check your work, and they're real AP exam FRQs, so they really kind of target the stuff that you're going to need to know. So this is another problem that is something like that. Oh, this is actually one that I recommend. This is one that I did. 2001, question 3 is one that I really like. So just some problems in case you need some more help. So I hope that this helped kind of going through the problem step by step, and that I was able to explain it well. So thanks a lot for watching, and see you soon. Bye!